Hello everyone, I'm Ayan. I'm joining you from Redmond, Washington, Microsoft HQ, and I am so excited that you're joining us on this brand new series, Modernize Java Apps with AI. Before we get started, let me tell you about one of the most surprising modernization failures in recent history. Does anyone by any chance know what this is? If you don't, this is the Louvre heist, and it happened a few months ago. And at first glance, most people would say it's a physical security issue. I mean, they took a ladder, they broke a window, they got in. But the deeper story is actually about systems that aged quietly. Technology that still functioned, but no longer met modern security assumptions. The system wasn't broken per se, it was working exactly as designed. However, weak passwords, outdated OS, delayed patching, temporary exceptions, which became permanent, all added to a layered exposure issue. Audits had flagged these issues years earlier, but nothing changed because of complexity, cost, fear of downtime, and this whole idea that everyone's afraid to touch something that's working until it doesn't. And this is what it feels like when trying to upgrade or modernize enterprise systems. And this is the problem that we're here to solve today, using the GitHub Copilot Modernize extension to put out the fire before we even smell the smoke, to be proactive. Welcome to the series where we're taking a deep dive into how GitHub Copilot can serve as a powerful agentic tool for your modernization workflows. In this series, we'll walk through the modernization journey step by step, from assessment and planning, upgrading Java frameworks, database migration and modernization, customizing modernization tasks, containerization, as well as CLI and pipeline automations. Each episode is designed to be 5 to 7 minutes long, focused on the practical fundamentals such that you are set up and empowered to start your own modernization journey. The best way to put what we are experiencing right now is an AI gold rush. 94% of executives say that AI is critical, but unfortunately, only 28% have scaled pilots into production. There is so much ambition, so much money being thrown at AI, but the execution gap is huge. And that's where modernization comes in. And this promise is sparking a renewed interest in the modernization process and putting greater pressure on developers and IT organizations to move faster to modernize at a greater pace than ever before. We see more demand than ever before to modernize decades of Java applications, to move legacy systems to the cloud, and to ensure that every app is ready for the AI generation. From our perspective, becoming frontier means that you are built on the foundation to support the future of your business. This moves modernization from something you would like to do into a key step that is both necessary and critical for AI adoption. Becoming a frontier firm isn't optional. It's about having the foundation to build what's next. And this is where the tool comes in. It provides a platform that streamlines the modernization of enterprise-level applications. It allows you to quickly perform end-to-end code assessments to discover core issues and insights about your application. You're able to use AI agents to upgrade your application into versions and associated frameworks which you want to increase app performance. You're able to make your apps cloud ready by automatically updating your code and dependencies to run on Azure. And you're able to leverage industry best practices and customize them for your organizational needs. On a high level, this is how the modernization loop looks like. Every customer, project, regardless of stack, boils down into these 4 phases. The first is assessment. It helps you get clarity on the dependencies, frameworks, patterns, and even CVEs. The second being upgrade. It allows you to move to supported frameworks and versions or target frameworks and versions. Migration, you shift to the cloud or to new platforms. And the fourth is testing and deployment. You validate, tune, and ship your code. I want you to notice how this mimics what a team would typically do. We are, however, using AI to supercharge the process. Also notice how it's an iterative loop. It doesn't terminate, it continues. And it can sometimes take multiple go-arounds at testing and validating changes but it will iterate like a human to get it done. The magic is that AI is doing it for you, and it's being done a lot quicker. We just looked at a simple loop. However, this is now an exploded loop of what an enterprise-level application might go through. This whole process comes together. Portfolio assessment tools, GitHub issues, AI agents, developer tools. And organizations usually enter this workflow in one of two ways. The first is that they already know what they want to modernize, in which case you start directly with the app modernization tool. However, more often than not, you don't know where to start, which is entry point B, in which case you can start with portfolio assessment tools such as Dr. Migrate, Cast, or Azure Migrate. These scan your on-premise systems and recommend which apps are best suited as modernization candidates. Once the assessment is complete, GitHub issues are automatically created, so every modernization opportunity becomes something actionable. Developers are able to pick up issues inside tools they already use, Visual Studio, VS Code, IntelliJ, whatever IDE you prefer. There's also no context switching. Modernization integrates with existing workflows. And the magic is when AI agents help with the repetitive tasks, which can sometimes take days. And these tasks include identifying outdated frameworks and versions, updating dependencies, automatically fixing issues and CVEs, migrating configurations, generating deployment assets, and containerization. And this is not a comprehensive list. GitHub Copilot is able to do so much more. And now you are able to focus on decisions, not the mechanics of those decisions. A process that used to take days can now be done in practically hours. And once upgraded and validated, you're easily able to move into staging and production rollout. Our goal has been that by connecting portfolio tools, GitHub issues, AI-powered workflows, you are able to modernize much faster than ever before with far less manual effort. And the whole process stays inside the developer workflow you already use. This series is designed to walk you through each part of this iterative loop. In the next episode, we'll start with application assessment using the GitHub Copilot app modernization extension to see how AI agents are able to supercharge perhaps one of the hardest parts of modernization, understanding what the heck is going on. Okay, that's it for now. I'll see you in the next episode. Welcome back to Modernizing Java Apps with AI. In this episode, we are diving into the application modernization assessment. One of the hardest parts of modernizing legacy applications isn't writing the code. Rather, it's understanding what you are working with and figuring out where to start. Oftentimes, you will start in a scenario like me. I have just entered the tech industry and I am inheriting code that I actually don't know what to do with. And assessment is a step that turns this uncertainty into a clear, actionable workflow. The goal in this episode is to demonstrate how GitHub Copilot can help you move from "this looks scary" to "here is a concrete plan," turning traditionally what would take weeks, months, or perhaps even many whiteboards into something you can understand and take action upon within the span of minutes or hours, depending on the size of your application. For this series, we're going to be using a ski shop e-commerce application developed by one of my colleagues, Yoshio, which represents a very real version or a very real representation of a legacy system you'll find in the enterprise world. This application is a monolith built using technologies that were common in the mid-2000s era. However, I'm a new developer, I have just walked into this mess, and I really don't know what to do. So let's use Copilot to get a bird's eye view of what we're working with. So I'll open up our project, and on the right side, we have our Copilot chat. I am using Claude Sonnet 4.5. We are in agent mode. That's not needed. Let's ask questions without making changes. So let me ask Copilot, hey, Copilot, I am just getting started with this project. Can you help me understand what frameworks and tools are currently being used from a bird's eye perspective? And now Copilot is taking it away. It is thinking, it'll scan the project. And hopefully in a few moments, we will see Copilot has given us some idea of what this project truly is. We can see everything it's reading. And this is the one thing I really love about Copilot. It shows you what it's doing. So you're in there, you're in there during the process. It's not just some magical black box. Okay, so we can see we have an output. Let's wait for it. Let's scroll to the top. So it says this is a legacy e-commerce application. It's a ski shop built as an application modernization demo. Yes, this is a demo. And here is the high-level technology stack. So we're using Struts. It's on Java 1.5, and that's crazy to me because release 2004 means that I was just starting elementary school. It uses Java server pages for views, servlet. It's a monolithic WAR file. It has layered architecture, tells us about the databases, utilities and supporting libraries, the build and deployment tools, testing, so on and so forth. And it's suggesting a modernization plan, but we'll get to that real quick. So from a modernization perspective, this application carries a significant amount of tech debt. There's high security risks, limited maintainability, operational and infrastructure challenges, difficulty meeting modern-day compliance and scalability expectations. Architecturally, this single WAR file actually consolidates what today would be considered multiple services, things like authentication, inventory, payments, loyalty points, user management, and order processing, all tightly coupled into one deployment unit. This makes it a realistic modernization candidate, not just a toy example, and we're trying to show you something from the real world in this case. So let's go back to VS Code, and let's open up the extension. You will see on the left side over here, we have some pre-built tasks. These are the different entry points. We have start assessment, upgrade Java runtime and frameworks, migrate to Azure, scan and resolve CVEs. These are all pre-built scenarios you can take advantage of. However, let's start with the assessment. And this step is a read-only non-destructive step. Nothing is upgraded, nothing is migrated. Copilot is simply just analyzing everything in our project directory to build an accurate picture of the current state. What the application assessment does under the hood is it analyzes the project using a combination of static analysis tools and rule-based inspection, including Microsoft's application modernization and analyzers. It evaluates things like Java version and language features, framework and library usage, build configuration, deployment assumptions, cloud readiness signals, known modernization and migration patterns. It's picking up on patterns. We're all human beings. And as issues are discovered, they appear in this cool, nifty UI in real time that I like to call mission control. And this makes the assessment feel less like a black box and more like a live diagnostics process. And we can see here in this case, we're 50% of the way there. It's running all these rules, 286 rules, and it is breezing through them. And we can see our little dashboard, or perhaps big dashboard, very important dashboard, being populated with data. So the application just completed. We can see the centralized report that we're presented with. It acts as a control plane for modernization. We can see the core application metadata, Java runtime and platform constraints. We're on Java 1.5, the identified upgrade and migration categories, cloud readiness, so on and so forth. So we can see there's 10 cloud readiness issues, 3 Java upgrade issues. 50% of issues can be covered with Microsoft provided solutions. This doesn't mean that you're just left in the cold for everything else, but it does mean that you're able to use either Copilot to generate a plan. If you open up Copilot, you can actually see there is a section or a extension or a selection for planning. It allows you to research and create multi-step plans, or you're able to create a custom task right here. And in creating a custom task, you are able to create repeatable workflows with your own custom references. So you can see we can add references And you can either give it a txt file, external links, or even commits. Going back to the assessment report, we see all of our cloud readiness issues. We see all of our Java upgrade issues. So this is the cool thing about the app modernization extension, because real enterprise applications always have edge cases. And the tool is designed to handle common repeatable work automatically while giving you full control of the rest of your application to allow you to create your own repeatable custom tasks. And it makes it especially valuable because it tackles one of the most difficult problems in modernization, breaking down large, unfamiliar, monolithic applications into understandable and actionable steps. Instead of guessing, you now have a shared document understanding of the application, a categorized view of risk and effort, a clear path forward from assessment to planning to execution. And this turns modernization from that everything is okay to an initiative that you're able to take, a developer-driven workflow. And that brings us to the end of this episode. I found it really exciting. I always love this UI because it's just such a nice way to take such a large project and put it into one visualization. In the next episode, we are taking a journey around the globe to Berlin, where my colleague Sandra will be taking this assessment output and showing us how you can move from insights to actions using GitHub Copilot Modernize, execute modernization and migration tasks, and accelerate real progress. Thanks for watching, and our team will see you in the next episode.
Hello, welcome everyone. My name is Sandra Ahlgrimm, and I got this app and I have to maintain it, upgrade it to a newer version. Let's see what we have here. So in the 𝗲𝗻𝗀, I can see that this is a Spring Boot Starter 159 project. It's using Java 8. Okay, fine. Why don't I open up my favorite IDE, which is here IntelliJ, and then I can use GitHub Copilot. I have two ways of using it. So I do install it via the plugins, and then it will appear here. Or I go into the AI chat, and as you can see here, I already installed it from the ACP registry. So here I just selected GitHub Copilot, clicked install, and there I have it. Also in the plugins, you can find the GitHub Copilot app modernization, which makes it even more easy. So now I can here, check this out, upgrade runtime and frameworks, migrate to Azure. Okay, for best results, use that model. Sounds about just right. So here it wants me to upgrade it to 21 LTS and also create a generate plan. So why don't I copy this one and do it a bit newer, Because why not? Upgrade to Java 25 LTS, invoking generate upgrade plan, also use Spring Boot for X. Okay, and I might even use a newer model since I do have enough credits also. So I will go with Claude Opus 4.6. Yes, that does sound about right. Okay, so why don't we go ahead and try that out? So here wants to use, okay, allow this session. So I love the fact that I'm here the co-pilot. So I always wanted to become a manager. Now I can finally, right? So I do have the agents that I'm managing here. So here's my project, and I want to go from the current one to 25. Okay, and here also it says it currently has the 1.8. It needs to use 25 in future. I couldn't find it yet in my toolings, but let's see. Okay, found the tools, and now it creates my plan. Here, look. Can see what I found here. So that's already true. I do have 1.8 installed. And I'm currently on a Windows 11 machine. Great. Oh, there we see more. So yeah, if you're interested, you can always make sure to check out the logs. Or you just wait. Or maybe with AI, we get some time to play a bit of table soccer again. I really love the fact. So here's also the progress. So we have the generate upgrade plan, confirm upgrade plan, set up development environment. This one is still running. Oh yeah, here's the installation of 25. Oh yeah, so the beauty of GitHub Copilot app modernization is that it's not only using AI, but also proven open source tools such as Open Rewrite. So here you can see that it generates a rewrite file. Okay, the upgrading is divided into 4 milestones. So first, we're going to use Java 21 and Maven 3.3. Okay, to then Spring Boot 3.3 and to then go further. That does sound about right. Okay, let's do this. So here in the progress MD, I can check. Oh, here's also the upgrade again. So now it's doing Spring Boot 3.3 and Java 21. Upgrade using the agent. Open terminal, that's what I can see here. And here again is my rewrite file. Yeah. Okay. So it's cool, I can use proven open source toolings without even the necessity of learning how it actually works. I mean, creating a YAML file is very complicated to some of our friends, huh, Bruno? Ooh. The -d parameter handling in PowerShell is causing issues. Potentially shouldn't have used PowerShell, huh? But okay. So now we have that one. Oh yeah, that was the issue. Okay, the recipes got applied successfully, no errors. And now we're removing the rewrite YAML again, because it's going to be a hidden secret. What we have used, I mean, obviously, it shouldn't be part of our production code, so that's why we're moving it here again. Okay, continue. So now it checks what got changed with the Open Rewrite one. So here we see the changes. So we updated Java X servlet to Jakarta. Then also the Spring Boot initializer got updated, and also matching messages get got changed to matching messages get first. And now it needs to build the project again to see if it's still running. Build project. Oh yeah, here are the CVE checks. So in the pre-check, you can also see how we run this, like Apache common thing, and then we also check the tests. So we see that we do have 96 tests. They're all passing currently. And now we are upgrading it with the agent. Here you can also see the logs, which is pretty cool. So everything that my AI agent is doing is not happening unwatched, obviously. Okay, so this one is working fine. Let's see what else we do have in the progress. So we upgrade Spring Boot from 1.5.9 release to 3.3.13. Those were the changes. Now we are building the project. Interesting. Oh, and now we go from 3.3 to 3.4. Okay, so this is milestone 2. As I said, I wanted to have Java 25 and Spring 4 something, and it identified that it can't do it that fast. So now it's going with multiple milestones. So first it decided to go to 3.3, and now it does 3.4, and then we do here the upgrading to Java 25. Yes. Now let me check if there are any usages of deprecated security manager API or zip error in the codebase. Oh, that's cool. So it always checks for CVEs, but also for such known issues. Okay, cool. And now the CVE checks are coming. All 4 milestones happen completely. So we do have Java 25. Cool. Oh, I can't wait to have that done. I mean, the managers hiring me, they thought the upgrading would take like weeks, months, half a year. It would be so cool. We do have Friday evening if I can get that done by the end of today, huh? And then I can finally take the time to do something so much more cool, like a greenfield, green grass project, right? You know what I mean? Okay, so let's keep the changes. Okay, so now it's running all the tests. Should also be able to see that here. Run tests, yeah, that sounds good. It's also checking for the behavior changes, what I do love a lot. So it checks what the code is for and what are like the features in place. And then usually makes sure that those features are still in place after the migration. I mean, it really has to happen, right? I don't want to break anything. So here are like the run tests where I can have the logs that looks good. Underlying exceptions. Oh, some mosquito checks. That those were most likely fixed. And then, oh, here's an error. Get Eclipse adopt you. Okay, interesting. Can't wait to find out how it got. And here it's again build result, compile it, validate CVE, still running the tests. And sometimes it's making me too nervous. I mean, come on, it's totally checking out what's happening. Yeah, so like here, Mockito. Cannot mock this. Okay, so the property overrides aren't taking effect. Spring Boot Bomb is still pulling the old byte body. Oh, that's why. So, okay. So now we're checking if it's an issue like compatibility. Maybe Java 25 is still too new that we don't have the byte body. Oh, so then it might tell me that I can't even upgrade to such a new version. But then it will also come with the text, right? So if the manager is asking me, hey, why did you choose 21 as the LTS and not 25? I can come up with a great, written down why is not possible yet to switch to 25, but we'll stay with 21 then. So yeah, the logs. Yeah, still the byte body exception. So let's see what AI will come up. Cloud Opus, please fix the issues for me, or if it's not possible yet, please tell me why. Oh, it would be so cool if it would go, in GitHub and then create the issue and then fix it even. But obviously, I don't want it to be that strong. I mean, there should be always some human in the loop checking out if there's already the GitHub issue in place and then does it for me. I also upgrade Mockito to the latest available version and ByteBuddy, which are the latest in Spring Boot 3.5 ecosystem. Okay, and now it builds it again. And let's see, maybe it's just a version compatibility issue. Close all the others. I just need to see the progress MD5. Fixed test. 1 file changes, 5 insertions, 3 deletions. Okay. ByteBuddy experimented true. Okay, that sounds about right. Now it's building the project again, running a Maven clean test compile. Okay. Let's see what happens. Oh, now it's also validating CVEs. That's always very important. Let's stay security first. And whenever we do a change, we should make sure that we at least don't introduce any new security issues. But since we are already touching the code, obviously, we want to make sure that there are no security issues in place. So that's why we run the CVE checks to make sure that it is all upgraded to the newest versions and fixed all security vulnerabilities. Okay, so and again, since we changed a few things to fix all the existing CVEs, we now need to do another code validation. So we check that there are no new features in place, but also all the old features are still running correctly. You can see how it does that. Trying to understand what the code actually does. Oh, done validating code behavior changes. That sounds about right. So let's see what's next. One test. Okay, so now we're running the tests again. Ooh, that's where it's going to be interesting. Great progress. Down to just one test failure. The process groups to service test expects something. Oh, that sounds good. Let's see. Okay. Wait, mock have I see the program. In the passes groups to service test mock request get header is member of returns null because the stub is not set. Oh no. Header is null, any strong no longer matches null in 𝗦𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 CVE instead. Okay, so let's remove unused any string. Okay, sounds good. Fixing the test. We run the CVE check again. Obviously, always when we do a code change, we always need to check that the CVEs are still not in place and that there's all good. Okay, so now we change the test again and do the upgrade. From opening the project to now, it's just 16 minutes by. I mean, come on, how great is that? Can't wait to see this one being successful. So how is the progress? Oh, there we have a test. Validate. Oh yeah, now the tests are running again since we changed them. Oh, still failing. What? Isn't being triggered. Returns not. Is a member of. Messages controller unit test. Let's see where we have that one. So we have tests, and then there is controller, and then there should be this one. Okay. Let's see if that does what it should do. Okay. This is distinction. Okay, use nullable string class. Okay. Well, as long as it's not null, if I said something, then it should be fine. So now it's running the tests all again. Very cool. Here's my input. And there should also be, oh no, that's the plan. Here's the progress. So here we can again see how the CVE got validated code. And there we have the tests, fixed test errors still. Oh, wow. Is member of header parser. Doesn't stop. Okay. So now it tries to fix and solve the issue by itself. At some point, it might say that it can't do it, so then I will be the human in the loop again. But for now, I will let it try it out. It really feels like I would have my own people that I'm managing here, but just in this case, it's the agent doing all the hard work for me, where I have my both hands free to cuddle my cat. Which does sound about right for migrating and all those boring maintenance tasks, but somebody has to do, right? And especially with the security CVEs in place, totally need to have that upgraded and maintained. to don't have any very, very bad issues in our production systems when we don't have upgraded services in place. And I do understand it, right? From the point of like management, if you have to like put in weeks, months, or even years to upgrade all the services, I do understand why they haven't done it, even though it causes security vulnerabilities. But now, with AI, we're still within 20 minutes. Let's see how we can get that fixed. Maybe I do have to install a new Java version. But, as I'm like super lazy and I want to have my agent doing all the work for me, I would just wait until it gets it. So it pretty much says the Java home variable is not defined correctly. So maybe I should help it and say, please define. So I do stop, tell it to do the Java home thing better, and then I can continue. Yeah, the current Java home is pointing to Java 24. That's it. Okay. Now it checks if it is available. Okay. So let me update the plan. Okay. Done validating behavior changes. Okay. Oh, that looks so good. Upgrade projects to use 25. Whoop, 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 whoop. Upgrade using the agent, build the project. 1% compiled, validation and fixing. Build project, no CVEs. And here are the tests. Oh, there are still a few warnings. See what it does. Yeah, terminally deprecated method. Okay. Here in Java 25 is still pretty new. Boop, boop. So it claims it did it all. Wow. Okay. Very, very cool. So it did 4 milestones. We have it upgraded from Java 8 to 25. In the end, it did the step with 21 in the middle and then 25. And here it says I need to restart my IDE to take effect. So why don't we give it a try and check if it's still running? Okay, so this one says it cannot run it because it can't find the... Okay. Start the app for me in IntelliJ. Okay, so let's see if it does that for me. So I really want to make sure that everything is still running. So I also want to test it like manually, right? Okay. So, okay, so now I can start it. Okay, in the terminal. Why would it be in the background? I want to see what it does, right? So maybe I do it here. Boo, 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 boo. Yes. You're allowed. You may access my network. Very cool. And there is my app. A Spring Boot 3353 application. Very, very, very cool. Very cool. Oh, it would have done the same. Not really in the background. So cool. Great. Oh yeah, and now it knows that I haven't run twice, obviously. But that's all right. So it's now port 8080. So why don't I give it a try and open it? Localhost, it says 8080. Ooh, it's up. It's up. There you go. I mean, the app is not doing much. But yeah, what I want to say, wow, that is just so cool. It did the upgrade for me. It comes up with a very cool plan, so I can even see what are the results and how many also CVE things were done. So now we still have the 96 tests that are all still passing. We switched the dependencies from 1.5 something to 3.5.3 Java 25. So I can make use of all the cool Java features, such as being more reliable, even more fastly, consumes less energy, less resources. So good. Just so good. And also all the potential issues that have been fixed. Very cool. And here are a few behavior changes, but not really resulting into any changes of my application. We've done this with GitHub Copilot mod in IntelliJ. It's also available in VS Code or GitHub Codespaces. Give it a try, migrate and modernize your application today. Have a lot of fun.
Hi everyone, my name is Yoshio Terada. So today, in just 5 minutes, I'd like to share my real experience with GitHub Copilot app modernization for Java. Let me start with a question. This Java app was built years ago, so honestly, I'm scared to touch it. Have you ever felt that way? When we talk about the modernization, the hardest part is not writing code. You don't know where to start, so you are afraid of breaking something, and just investigation that impact can take weeks. So we all know the 6R approach or the 7R approach for modernization is very important. So for example, rehost, refactor, re-architect, rebuild. So such as the R 6R or the 7R approach is very important for the modernization. That in reality, many teams are stuck at very first step. For people feeling difficult such as things, so I want to introduce a very practical tool. So GitHub Copilot modernization for Java. It doesn't just writing code. It helps you understand all of the project and create the migration plan and actually start the migration. So let me briefly show you an example. With an app modernization for Java, you can check the project using the assessment tool, and if you executed the updated button, the agent first creates a migration plan from the existing project analysis. And based on the plan, the migration is executed step by step. In this time, I created the monolithic ski shop application built with Java 5 and the Struts 1.3. In order to upgrade Java 21 and the Spring Boot, I review the created plan and define it and add my own custom instruction. So I also create and use a custom verification skill to check for mistake or missing part of the AI implementation code. So this kind of plan and the verification skill is very important. So let me honest. So AI is not perfect. So sometimes it will make mistake. That's why planning and the verification are critical. To achieve the implementation I was expected for, I extensively revised the migration plan documentation and developed a far more detailed and well thought out plan. plan. But here, the biggest difference was that in the past, it will take around 14 weeks by human. But it can now be done in about 2 days with AI. So actually, I could migrate the application from Struts to Spring for only 2 days. To me, GitHub Copilot is not just a Java coding tool. It's your first paradigm when facing the legacy system. You don't need to modernize everything. Just start by asking, so please let me know the best way to modernize the current system. That alone makes the first step much easier. So please try it. Thank you very much.
Welcome everyone! When we have to modernize and migrate our databases from Oracle DB to PostgreSQL, we also need to make sure that our Java apps have the new dependencies in place, and also a few function calls might have to be updated. So why don't we clone this repository here under the Azure samples, the Java Migration Copilot samples, and then open that up in our favorite IDE. One of these could be IntelliJ. I do have Copilot here in place. You could also open that up with the AI chat, and then when you click on install from ACP registry, you can make sure that you do have your favorite GitHub Copilot installed, updated. Updating is always a good idea. And then apply. Okay. And we are ready to use it. Please do as written in the README file for the to-do web API with Oracle DB. And I do have here GitHub Copilot. I want it in agent mode. And here I can also select the models. I would go with Opus. Okay. Oh, I do have a typo here, but for AI, it should be okay. So it's now reading the README file. It seems to have the right one. It's also checking out what are the dependencies in place. The source words, the main Java resources. Okay, interesting. So in the README file, it tells us what the app is using. That's might be the reason why it checks out the files as well. And then wants me to make sure that I do have Java 17 in place, Maven 3.8 or higher, Docker to run the Oracle container Postman or any API testing tool. And then also Spring Boot 3 to 4, JPA, Lombok, interesting. And then it basically asked us to run the Oracle DB here with the container. So let's see if it does it. Okay, this one is kind of going ahead and it totally wants to, I will totally stop this. So let's open Copilot chat. Please start the app to review or to manually test its current behavior. Yeah, okay. So now I have the README file open, so it knows that I mean this one. And now I asked it to start the app. Okay, so now it wants to run as prescribed here because the Oracle thing is already there. Okay, that's very weird because if I open that one and then so now it does the Spring Boot application. Oh, we do have a build failure. Oh, maybe it's already running. Let's see. Okay. Yeah, it tells me that it needs to sleep for 15 seconds to just make sure that everything is up and running before it starts it. Okay, so here we do have Java. It checks what version we're having. Okay, so currently I do have 24 in place. Let's see if it can upgrade it automatically for me, just setting up the new Java home version. For future, I should, by the way, use something like SDKman. Nowadays, we need to switch so often between Java versions. That might be a good thing. Oh yeah, here's the app in place. Why is it opening an app multiple times? Anyhow, so here's my Spring app. So why don't we open the app? So I do here have the localhost 8080. And I assume I get a white label error because nobody put in the, and then there were some API to-dos. So for instance, here the completed ones. So it gives me 3 review pull requests. Okay, priority 7, due dates. That does seem about right. Okay, so here are a few commands. You can try them out as well. Yeah, here's the, all right, so here you can also check out what I'm having. I'm on Windows here, so I would do it like that. Yeah, so here I also get the same kind of results. So ID 5, update dependencies. So this is me basically talking with it. And here I could also create a new to-do item. For instance, here, learn GitHub App Modernization for Java. Oh, that seems to be a good one. So happy we're already on it. So here it says bad request. Interesting. So something might not be right. What's wrong here? Yeah, so here's also JSON pass. Okay, so the issue might be with the local date time. Semicolon. Okay. Yes, please. Yes, please fix, test the app, and also update in README. However, we do want that the others will not run into the issue. Still running on 8080, so it checks if I'm still here, and then it does do the GET request first, test the endpoints. It also checks if the post one is working. It still doesn't seem to work well. Two issues in the README. Date format bug as well as PowerShell issue. Okay, very good. Let's see if it does it now. Oh, that looks good. So now I do have the correct post request. On the fly, I obviously updated the README file so that the next users will not go into the issue. Very, very cool. There it is. Okay. Cool. So now what I want to do is I want to make sure that so now what I want to do is I want to make sure that we can move away from the Oracle DB towards PostgreSQL. So why don't I open up the GitHub Copilot app modernization? I installed it via the JetBrains plugins. And here you can find the upgrade and runtime frameworks and also the tasks. And here with tasks, I should also have migration, database tasks. And there you have it. So here is migrate from Firebird to Azure, for instance. In this episode, I show how you can customize GitHub Copilot modernization tasks in IntelliJ. So Copilot works with your constraints, not against them. When Copilot modernizes a Java application, it doesn't just change code. It creates explicit modernization tasks, and those tasks are fully editable. That's the difference between automation and developer-controlled modernization. Copilot analyzes the project and proposes a set of modernization tasks. Think of these as a first draft, not a final decision. Now we have something tangible, a task list that describes what will change, why, and in which order. Real teams always have constraints. Here I'm explicitly telling Copilot what not to do. Instead of one risky step, I break this into smaller, reviewable tasks. You can also add your own requirements, just like you would in a real backlog. This task list now reflects our reality, not a generic upgrade path. Copilot adapts to the constraints instead of ignoring them. Tasks are applied one at a time. Nothing happens without review. When teams modernize Java applications, the real risk isn't the tooling. The risk is making changes you didn't intend to make. That's why GitHub Copilot modernization is built around explicit tasks, not automatic rewrites. In this screencast, you just saw I generated a modernization task list, customized it, and deliberately excluded the Java and Spring upgrade. Instead, I ran a regression and deployment safeguard task to validate the current state of the application. And the most important result is no files were changed. And that's the correct outcome. Project built successfully. Deployment scripts are untouched. Nothing about the runtime or infrastructure was modified. Copilot also surfaced two important facts. First, there is a failing test, but it's a pre-existing issue, unrelated to modernization. 𝗦𝗲𝗀𝗀𝗀𝗀 cannot mock a final class from the AWS SDK. Copilot correctly identifies the cause and explains the proper fix without trying to guess or to patch it automatically. That's exactly what you want from a modernization tool. Second, Copilot identifies known CVEs in the here used Spring versions. But because we explicitly excluded the Java and Spring upgrade, Copilot also explains that these vulnerabilities cannot be fixed within the current constraints. Again, no silent changes, no unsafe assumptions. This is what customizing modernization tasks really means. You tell Copilot what is allowed, what is blocked, and what must be verified. And Copilot operates entirely within those boundaries. Modernization isn't always about making changes. Sometimes it's about proving that now is not the right moment and having the confidence to move forward with that knowledge. In the next episode, we'll take the next step and look at how to unlock a sequence higher impact modernization task once the prerequisites are met. But it always starts here with clarity, constraints, and developer control. Like and subscribe to not miss the next episodes, and check out GitHub Copilot Modernization in your IDE of choice.
Hello, everyone. Welcome back to our App Modernization series. Today, we're talking about containerization and deploying to Azure and how Copilot is able to help assist you with both of these tasks. We'll start back in VS Code with our ski shop application already upgraded to Java 21 and building successfully. This is an important prerequisite. Containerization, or the containerization assist, usually works best once an application is already running on a modern supported Java runtime. However, I did, just for fun, containerize this application before modernizing or upgrading, and Copilot did make some changes to the application, and it was eventually able to containerize. This is the neat part about Copilot. It can be proactive and take steps as needed to reach the end result, of course, with your permission. So at this point, the app is functionally complete and ready to be packaged and deployed. So let's open up the App Modernization extension. And on the left sidebar over here, we can see this section for tasks. And these are all pre-built tasks that are provided by Microsoft to cover some of the most common modernization scenarios. You don't have to script these workflows yourself. I'll expand common tasks. And in common tasks, we can see containerization tasks. So we'll select that. And when I click on Run Task, Copilot takes over and starts to understand the application. Before making any changes, Copilot does exactly what a human engineer would do first. It analyzes the project, it scans the repository, and understands the structure, reviews the build systems, runtime configurations, and then creates a containerization plan. In addition, you can see eventually we should have a checklist show up at the bottom, which shows us all the steps that Copilot will take. Sometimes it also shows up in the plan, so we'll wait for Copilot to finish thinking and present us with our upgrade plan so we can review all the steps that Copilot plans to take on our containerization journey. All right, so here we can see our to-dos. We have 7 steps: analyzing the application configuration dependencies, creating the containerization plan document, checking the prerequisites, reviewing configuration readiness, generating Docker files, and then building the Docker image. So we can see it's asking for some permission. It wants to run a bash command. For the purpose of this demo, I will say allow all commands. Of course, I say this with a little bit of hesitancy. Do it at your own risk. You know, in production environments, there's always a lot more weight on your shoulders. So it is good to follow that human in the loop cycle and not rely too much on AI. So we can see the plan has been created over here, and it's in a nice little markdown file. So this file lists exactly what services will be containerized and what steps Copilot intends to execute. Once the containerization plan is ready, Copilot opens it as a markdown file. This file lists exactly which services will be containerized and which steps Copilot intends to execute. If needed, you can edit this plan to fit your project's requirements. In this case, I'll say the defaults look good, so I'll continue to allow Copilot to run the commands. And real quick, we can take a look at everything that's in this modernization plan. We see the configuration requirements, the execution steps. It's a procedure. Copilot follows the procedure, which is great for us because it's easy to understand. And in this case, because I had allowed Copilot to continue with auto approval, it is continuing automatically. And in the time we reviewed the containerization plan, we can see it's almost built the Docker image. And once it builds the image, we will see it validate the results and present us with a containerization summary. So we'll wait a moment as it finishes up, and we'll be right back. Okay, so we can see that containerization is complete. It is giving us a containerization summary of everything that Copilot did. It says successfully containerized. Here's what was accomplished. Created the Docker files. It did some code changes. The Docker image that was built. The size of the Docker image. Some key features. And it says to run with the PostgreSQL database, we can use this command. However, in this case, using the PostgreSQL database likely won't work because we do want to test it locally first. So I'm going to ask Copilot to use our built-in H2 database. So I'll tell it I want to test the application locally using my H2 database. Can you make the necessary changes? Enter. And we'll allow Copilot to make those changes so that way we can test locally before we deploy to Azure. At this point, the application is fully containerized, so we can see the pop-up which says the application is running on port 8080. Let's go ahead and open it, and we see it is up and running, our ski shop. We can view all products. We can see all these products. We can see there's a slight bug. It's using the wrong currency, which is to be expected. This is a demo that was created by my colleague Yoshio, who's in Japan, but nothing that Copilot can't easily fix. For this purpose, we won't worry too much about it. It's a pretty small issue. I'll take care of it real quick. And now let's jump back to VS Code and get started with deploying to Azure. So once again, I'll go back to the tasks section here on the left, and I'll expand the deployment tasks this time, and we can see there's 4 different pre-built tasks, which is deploy to existing Azure infrastructure, provision infrastructure and deploy to Azure, generate infrastructure as code and provision, generate CI/CD pipelines to deploy to Azure. So in this case, I will select provision infrastructure and deploy to Azure since we're starting from scratch. And we can see Copilot is scanning the project and taking over to figure out what needs to be done. So we can see Copilot follows the same pattern as before. It will scan the project, it will generate a deployment plan, and finally, it will ask for approval before executing anything. So we can see now, let me create a comprehensive deployment plan. I'll click on Allow. This time I have not selected the auto approval just yet because I do want it to pause for the deployment summary. So we'll give it a moment as it thinks, and we should have a deployment plan in just a few moments. So we can see that it has created the deployment plan over here. So the goal of the deployment plan is to deploy our ski shop application using the Azure Developer CLI with bicep used to define infrastructure as code. By default, it will be targeting Azure Container Apps. You can change it to AKS or something else if you would like. We can see everything that the plan includes, which includes an architecture diagram, includes the architecture relationships, recommended Azure resources that it will provision, dependencies, recommended supporting services, the security configurations, execution steps, which are very well laid out, and then progress tracking tools it will use. So once again, you can make any changes as necessary, but in this case, it looks good. We'll open up Copilot once again. We will allow it to continue, and it will execute the deployment step by step, generating the bicep, YAML files, validating the infrastructure, provisioning Azure resources, deploying the container image, and finally generating a final deployment summary. Copilot handles the repetitive, error-prone work automatically while keeping me in the driver's seat of the decisions. So I won't make you wait through this whole process. Like we talked about earlier, it is an iterative cycle. It can take some time, but you are free to go up and take a snack break. So let's take a break, and I will be back once the application is deployed. Okay, we are back. So the application deployed, I have the Azure portal opened up. We can see all the different resources that were created and deployed. We see our container app, and we can click on the application URL to take a look. I did ask Copilot in between to fix the currency issue. I don't think it actually converted it yet to dollars. It just changed the symbol, but that's okay. It's an easy fix. It's a database. It's just a database information thing that we need to take care of. But in terms of the application working, it seems to be, doing everything that it should. You can add things to cart, proceed to checkout. We have our checkout page. We can log in, sign up, so on and so forth. So in this walkthrough, we took our upgraded and modernized Java 21 application, containerized it using built-in tasks in GitHub Copilot, validated it locally, and deployed it to Azure, all using the same agent-driven workflow. Copilot doesn't replace developer judgment, but it dramatically accelerates the mechanical steps that normally slow down teams. In the next episode, we'll go deeper into how we can use the Copilot CLI to scale up the modernization process with batch processing, as well as CI/CD pipelines. Okay, we are almost done. We will see you in the next episode. Hello everyone, welcome back. Up until now in this series, we've been working inside the IDE, running assessments, reviewing plans, and modernizing a single application step by step. However, in this episode, I want to shift the perspective and move that same workflow into the terminal. The application we're using today is Java Social. It's a purpose-built application that mirrors the kind of systems many teams are still responsible for using today. It's not one clean repo or one technology stack. It's a small distributed system with multiple services, different runtimes, and older assumptions baked in. In fact, there's 3 separate repos. There's a backend service, which is an older .NET stack exposing SOAP-based endpoints and backed by a relational database. There is a Java front-end built with JSPs and servlets, talking to the backend through a hand-roll SOAP client. And then there is a background worker, also Java-based, pulling messages off a queue and asynchronously forwarding work to the backend. Each service lives in its own repo, has its own build system, its own runtime constraints, and its own upgrade path. None of them can realistically be modernized in isolation, and none of them benefit from opening just one in the IDE and clicking through a single wizard. This is the point where modernization usually slows down. Teams start juggling spreadsheets, tracking work across repos, and manually coordinating upgrades one service at a time. Instead, we are going to use the Modernize entry point in the CLI to kick this off from the terminal. For this, you're going to need GitHub Copilot CLI installed and configured with the app modernization tools. We'll be spinning up multiple agents to access these repositories in parallel to generate assessment reports and plans, and then review the results directly on github.com, just like you would with work produced by another engineer on your team. I'm going to keep the demo itself mostly freestyle and focus on what matters, which is running a command and letting agents handle the mechanical analysis, and then making decisions based on real reviewable artifacts. So let's go ahead and jump into the terminal. We will use the modernize command in the Copilot CLI to invoke the modernization tools. It will scan the folder we're in and it finds the 3 repositories. I will select all of them and we see Copilot asking us, what would you like to do for all your repositories? We can understand the applications or upgrade them. So we will start by understanding the applications. And then it asks, how would you like to assess all your repositories? Locally, or do you want to delegate them to cloud coding agents? We'll delegate them to cloud coding agents because it's significantly more efficient. GitHub is able to create multiple Copilot instances that work in parallel. In this case, we will see that we get 3 different agents, 1 assigned to each of the repositories. So we can see Copilot delegating and assigning the different agents, getting them spun up. And once it finishes doing that, we can then go to github.com and we can track the progress of our agents as they continue to work independently. So we can see 2 out of 3 of them have spun up. Let's go ahead and jump into github.com. So if you go to github.com/copilot/agents, you can access all the agents that are currently running. We'll refresh the page. Hopefully the 3rd one is also up and running. There it is. So we can see 1 working for the front end, 1 for the social worker, 1 for the back end. It'll take a few minutes for it to complete, so we'll let it do its thing, grab a snack, and we will be right back as soon as they finish. And we are back. So we can see 2 out of 3 of the Copilot agents have finished working. Let's go ahead and open the front end. We can review, if you're interested, we can review everything that Copilot went through. It's like it thinks out loud for us, which is really helpful. We can view the pull request, but what we're really interested in is the assessment report. Okay, there we go. All 3 of them have finished running. The CLI should update briefly once it pulls again that we have 3 completed. It's downloading the assessment results, and once it's downloaded the assessment reports, we should be able to take a look at Copilot's findings across the 3 repositories. Okay, it finished downloading. Let's go back into our local folder. Yes, we can see here's our aggregate report, and it might still be generating our HTML file. Yes, it's still generating. Oh, there we go. So now it's popped up. So here's our consolidated assessment report. We can see there are 3 total apps which are scanned. 2 upgrades are needed, 7 blockers, 2 potential issues, the current technology distribution and frameworks, and all of the recommendations from Copilot in terms of the migration plan. And at the bottom, we get more detailed information regarding each separate application and the steps we need to take. So this is great information. This is the dashboard. This simplifies one of the most difficult steps in the process, which is getting a bird's eye view perspective of what's actually going on with an application with multiple repositories, hundreds of files, hundreds of folders, and so on. So let's jump back into the CLI. And we will now actually go ahead and execute on the upgrade. Now we get to the fun part. And like before, we will delegate to the cloud. So that way we have 3 different Copilot agents working in parallel to help us achieve our migration goals. So Copilot says, I'll invoke the create upgrade plan skill to generate an upgrade plan. And once it starts doing this, we'll be able to jump back into github.com and view our cloud coding agents. We can see it generated an upgrade plan right here. And that is the upgrade plan that it's currently using. So we can jump back in here. And find the upgrade plan. Modernize, here it is. And this is our plan. It's in Markdown format. So it should look nicer if you preview it, but we can see the upgrade plan that it's following. These are the objectives, the tasks, and the tasks are in a separate document. And this is how essentially Copilot creates a procedure for everything that it will follow through on. And once it created the plan, we can look at the other outputs in the CLI, what Copilot is doing. And it says the upgrade tasks were submitted successfully to the cloud coding agents. We can press any key to continue. Let's go ahead and open up Copilot again on GitHub. And we can see we have our 3 agents working on each one of the 3 repositories. All right, so I won't make you sit through that. But what I really wanted to highlight is we aren't changing how you modernize an application per se, but we're changing how and where that work runs. Running modernization through the CLI means the same workflows you saw in the IDE now work in places developers already automate things: scripts, CI/CD pipelines, schedule jobs, and batch runs across repos. You still get the same outputs: assessment, plans, diffs, and pull requests, but now they're produced at scale and reviewed the same way you review any other changes in GitHub. The important part is that this stays reviewable and controlled. Agents do the repetitive work, scanning the code, generating the plans, applying mechanical upgrades. And they leave behind artifacts that you can inspect, tweak, and even reject. Nothing is hidden. Nothing skips the usual engineering checks. Once you have that, it's not hard to imagine pushing this further, running assessments across dozens or hundreds of repos, applying the same upgrade rules consistently across the whole estate, wiring modernization into CI/CD apps so that apps don't quietly fall behind again. At this point, modernization stops from being a one-off project and starts looking more like regular maintenance, something you run, review, and move on from. All right, we're wrapping up. We'll see you in the series conclusion in the next episode. All right, you made it. Over this series, we worked through what modernizing a real Java application actually looks like. Not just a single tool or a one-time project, but as a true practical engineering workflow. We started with uncertainty, unfamiliar code, outdated frameworks, mixed runtimes, multiple repositories, and usually low confidence about where to begin. However, instead of jumping straight into rewriting code, we followed the process that a typical migration upgrade would go through. We focused on the assessment, understanding what we're working with, what's risky, and what's actually blocking progress. From there, we moved on to the planning and execution phase, upgrading Java runtimes and frameworks, addressing configuration and dependency issues, modernizing databases, customizing workflows when the defaults weren't enough, packaging applications into containers, validating them locally, and deploying them with repeatable infrastructure. As the series progressed, the scope expanded. What began in the IDE, we moved into the terminal. The same assessment and modernization steps were applied, however, this time across repositories at scale, run in parallel in the cloud. And what we got in return were reviewable artifacts in GitHub, plans, diffs, and pull requests, not just black boxes. The key idea throughout has been modernization and migration aren't finish lines. They are ongoing engineering tasks. AI-assisted workflows don't replace developer judgment. They are able to scale it. And they're able to take on the repetitive mechanical work, analysis, plan generation, dependency updates, so you as developers can focus on architecture, correctness, and long-term direction. Instead of treating modernization as something you avoid until it's unavoidable, it's become something that you can do continuously, the same way you manage tests, security updates, and dependencies. That's where this is headed. Modernization workflows that fit naturally into how you as teams build software, run from IDEs and terminals, scripted, batched, and integrated into CI/CD pipelines. It is reviewable, auditable, and under developer control. This series really focused on the fundamentals, just enough to help you get started and understand how do these workflows apply to your own applications and environments. We've linked additional resources and learning paths in the description if you want to continue the exploration. We are so glad that you followed along with us on this journey, and we hope to see you around either in person or online. Thank you.